Hello everyone, this is Dr. Rajesh and today I am with you with my next video lecture on numerical problems on projectiles. And the problem today that we will take in this particular video lecture is shared by one of my student. So we will deal with that problem, and before moving to that problem we shall write three important formulae that we have studied in the last lecture and that will be used in the numerical problems of the projectile. First one is time of flight. Second one, horizontal range. Okay, and third one is greatest height. These formulae we have said is represented by H, this is represented by R, this is represented by T. For this you will write U square by G, and here you will also write U square by G. Why U square by G in both? Because horizontal range is in meter, greatest height is in meter. So what is the units of this U square by G? U is a velocity having unit meter per second, and G is acceleration having unit meter per second square. So this has unit meter square, second square, and this will be second square meter. This will cancel out, this will cancel out, this is equal to meter. So both are heights, so therefore both have the units of meter. So U square by G is in both of them. And here we will write U by G, and what is the unit of U by G? U by G is meter per second divided by meter per second square. U is velocity, so this can be written as meter per second dot second square meter. Meter to meter will cancel out, so we are left with second. So U by G is unit of second, which is time is in seconds. Okay, and thirdly I am showing you way how you will keep it in the memory. This will be sine. So in all the three you will write sine. Here you will write alpha, here you will write 2 alpha, and here you will write sine square alpha. Now see, here 2 has come with sine, so no 2 will be used. Here 2 is not present, so here we will use 2 in multiplication. But here instead of 2, sine alpha into sine alpha, sine square alpha is there, so it looks something more is with that third formula. So to compensate it, to negate it, so counter its effect, we need to divide it by 2. That is just the way to show you how to keep it in memory. Okay, so that is how we will write all these three formulae, and these are important formulae, believe me. And to just do the numerical problems on the projectile, you have to keep it in mind. And later we will also be requiring the formulae for focus, vertex, axis, directrix. We will be dealing with that, and I will also be writing those formulae, so no need to worry. So now I will be sharing with you the problem, and the problem is shared by one of my students, and the problem is as follows. If R be the range of projectile on a horizontal plane, R is the range. So let me do it. Let us say R is the range of projectile. And you know what is the formula for range of projectile? Here you will write U square G, and it will be sine 2 alpha. Fine. So this is the formula for range we have used. Now next, read out the statement. At its maximum height or greatest height for a given angle of projection, and angle of projection here we have taken as angle of projection. You could mention that alpha is angle of projection. U is the velocity of projection. U is velocity of projection. Okay, so this R is the range. Now next, H is the greatest height, so H is equal to greatest height. Fine. And you know for greatest height it is U square by G, I have already told you this is sine square alpha, and if it is sine, here will be 2. So this is the greatest height. Now required to prove that maximum range with the same velocity of projection. So we have to prove that R max is equal to 2h plus r square by 8h. This is required to prove. Also show that velocity of projection u is equal to 2g h plus r square by 16h whole square raised to the power 1 by 2. So this is also required to prove. So this is the question. So we are given the range of projectile and greatest height. See how we proceed further. Let us draw the figure, and figure is given by, look at this is the figure. O is the point of projection with velocity, initial velocity u, and angle of projection is alpha, and r is the range which is given by, and h is the greatest height. We have to determine the maximum range it can go on, and maximum range we know is corresponding to alpha is equal to pi by 4. So that we have to prove R max, and next we have to show that what is this velocity of projection. So we have to prove this is equal to this one. So we have two formulae with us. So if we see, name it as equation number 1 and name it as equation number 2. Now divide 2 by 1. We will get h by r is equal to u square by 2g sine square alpha divided by u square by g sine 2 alpha, which is further equal to, this will cancel out, u square will cancel out, this is equal to sine square alpha upon 2 sine 2 alpha, which is further equal to sine square alpha to 2 sine alpha cos alpha. This will cancel out, this is equal to tan alpha by 4. So this implies that h by r is equal to tan alpha. This implies that tan alpha is equal to 4 h by r. Now here see, in both the expressions we have sine alpha, like here we have sine square alpha, and here will be sine alpha cos alpha. So sine alpha here will be also there. So we need to determine the value of sine alpha. So tan alpha we have determined. So can we complete this particular triangle and say this angle is alpha, and since this is tan alpha, so this is 4h, this is r. Okay, so this will be r square plus 4h square. In right angle triangle, you know this formula. So from here, if I say what will be sine alpha, what you will say, it will be this one upon this one. So this will be 4h divided by r square plus 16 h square, and here is the square root, and I am going to name it as equation number 3. So this is the formula. So I am again writing from 1 and 2. We have r is equal to u square by g sine 2 alpha, and h is equal to u square by 2g sine square alpha, and r max is observed, maximum range is observed if alpha is equal to pi by 4, that we have done in the previous article. So r max will be put over here, alpha is equal to pi by 4, so this will be sine pi by 2. So u square by g sine pi by 2, so maximum range is u square by g. So you are going to name it as equation number 4. Now from this equation, if I write u square by g is equal to 2h by sine square alpha, and name it as equation number 5. From 4 and 5, if I say r max is equal to 2h by sine square alpha by 4 and 5. So what is the value of sine alpha? So this will be equal to 2h, and sine alpha we have calculated h by, from equation number 3, 16 h square, and here is the square root and its whole square by 3. If you will see 3, so this we have used. Now this will be further equal to 2h by 16 h square, and it will be r square plus 16 h square. So this will cancel out, it will be 8, h will cancel out, so this will be 1 by 8h r square plus 16 h square. So this will be r square by 8h plus it will be 2h. So this is equal to 2h plus r square by 8h. So this is the maximum range. So that we need to prove that maximum range is equal to this expression. So this we have proved that maximum range is this one. Name this as equation number 6. Now next we need to find the velocity of projection. If we look at equation number 4, equation number 4 gives r max is equal to u square by g. So we are going to use the equation number 4. So using equation number 4, I will write here, using equation number 4, we get, what we will get? We will get r max is equal to u square by g. This implies that u square is equal to r max into g, and r max from equation number 6 is 2h plus r square by 8h g. Fine. If I take 2 common from here, it will be 2g h plus r square by 16h. So this is implies this is u square. So this implies that u is equal to, take this square root on both sides, 2g h plus r square by 16h and the whole raised to the power, and you may say that it's square root. So this is the velocity of projection, and name it as equation number 7. So here we need to determine two things. R max we have proved is given by number 6, and velocity of projection we have determined given by equation 7. So both things we have determined. So this is the solution of the problem that was asked by one of my student, and so I have dealt with that problem. So in the next lecture we will dealing with another problem of the projectile, and hopefully I believe that problem will also be shared with one of my student. So if you have liked the lecture, please like, subscribe, share and comment in the comment section. Your comment in the comment section are always valued, welcome and appreciated. This is Dr. Rajesh saying you goodbye. Thank you for watching and take care.